Assalamualaikum and good days. First of all, I would like to introduce myself. My name is Dr. Azwad from University Science Malaysia, School of Computer Science. Together with my team today, first is Ismail Faruqi bin Faisal. Second is my PhD student, Muhammad Naim Afifi Baisha, and also CEO from Asia Tech Technology. Next is Dr. Nomarinah Binti Alias from UITM Shah Alam. Fourth is Associate Professor IR Dr. Ernie Hamiza Hamza from UITM Permatang Pau, and also Nurul Iza Irdina. Today, I would like to present our project titles with development of virtual autonomous robot in digital twin enhancements using ESTA algorithm with Internet of Things capabilities. Before we start our presentation, I would like to give some overview of our project, where this project basically focus on the digital twin development, where we transform the actual activity into the virtual or simulations. So we're focusing on the development of the autonomous robot, where the traditional robot or basic robot without algorithm are not really smart, so that we need to align with the development of autonomous robot that existing using the robot operating systems. So we need to study how this kind of algorithm can be implemented in the virtual environment. So that, as shown in the video, there is a robot with the cursor. So with the ESTA algorithm, the robot will find the cursor with the shortest path, right? So to make the robot more intelligent and practical, and this should be aligned with the physical robot, where it can be tally between the virtual and also the simulation. So this is one of the application of AI that we enhance in the virtual twin. So next, I will pass to my team to present the overall of the project and architecture of this system.
Introduction. Autonomous robots have emerged as a critical components in smart manufacturing and logistics, where they streamline tasks like material handling, load movement, and transportation. However, managing and optimizing robotic operation in complex and dynamic environments present significant challenges. Digital twin technologies is a virtual replica of physical asset that enables real-time monitoring, simulation, and data analysis. By creating a digital twin of autonomous robots, industry can observe and analyze the robot's performance in real time, anticipating potential issues, and make it informed adjustment to improve overall efficiency. This project focuses on developing of autonomous robotic system enhanced by digital twin technology, utilizing the ESTA algorithm for optimal pathfinding. Integrating Internet of Things allow the system to be monitored and controlled remotely, ensuring greater flexibility and real-time decision-making. This project aims to demonstrate how digital twin enables autonomous robots can drive innovation in industrial automation, supporting safer, more efficient, and highly adaptive operation. The first problem statement is the traditional pathfinding techniques often struggles to provide robust and efficient solution in dynamic and complex industrial settings. Lack of real-time monitoring capabilities make it challenging to effectively manage and adapt robotic movements, particularly in large-scale applications. The A-star algorithm's precision and adaptability will enable the virtual robot to operate reliably, minimizing delays and unnecessary movements. The A-star algorithm is a well-known heuristic search function that excels in calculating optimal path by balancing computational efficiency and accuracy. The third one, the user-friendly platform will foster greater engagement and ease to use, reducing the learning curve for operators. Using Unity, providing operators with intuitive interface to visualize and manage the virtual robot's movement. The interactive design will serve as a central hub, data monitoring, path visualization, and manual override control. Real-time feedback allows operators to monitor the system functionality, detect error, and make adjustments as needed. For instance, if obstacle is detected in the robot's path, the IoT-enabled system can instantly alert the operator, providing the updated pathfinder information, and execute necessary changes without significant downtime. The project subscription. Digital Twin, which is the system, aims to create a virtual environment that mirrors the real-time movement and decision of autonomous physical robot. Virtual robot pathfinding using ASTA algorithm is applied in the virtual environment as AI solution to the system. Integration of IoT architecture for continuous data exchange from virtual button sensors as a mimic location of machines for a physical robot target path. The system also provides real-time monitoring robots movement using .NET framework for the Windows desktop. System objective to develop real-time shortest pathfinding virtual robot solution using ASTA algorithm inside the Unity script with .NET framework. To develop real-time feedback on the pathfinding solution using IoT architecture with MQTT protocol. To design databases for robots location and area log using Firebase cloud computing and Firebase database service. To design user interactive platforms for robotic path movement using the Unity for the system application, which is just app. Proposed solution, we have four. The first one is pathfinding. As the algorithms will calculate the shortest route for the autonomous robot, and then it will generate navigable path using the real-time adjusting for the changes or obstacles. Then this is the formula for the ASTA algorithm. Second is the simulation. I am using Unity Desktop to create a virtual representation of the robots and its environments. User can observe the robot path, view simulated obstacles, and also it can mirror real-world conditions without requiring a physical robot. User interface. User-friendly platform for operators to control the monitor, for control and monitor. Display crucial information, which is robot status, path data, and the real-time feedback, and also includes essential component for interaction and troubleshooting. Finally, we have the IoT, which is the virtual one. Virtual board location. I will be using web tags for the IoT and also the implementation of the MQTT. The data transmission between digital twins and the IoT enabled services using MQTT for efficient data flow for seamless integration with IoT ecosystem. It will facilitate real-time feedback and updates from the virtual environment. This is the module diagram for the system. First, we have the IoT module, which is a virtual board location. The data from here, which is the location of the robot, will be sent to MQTT using HiveMQ, and then will be processing in the cloud for Firebase, and then also will be sent to Unity for scripting. And then from that, Unity scripting will generate the shortest path in the system, and then will return a value for the path, which is the shortest path. And then the path will be sent to Unity for simulation. And then he will display all the necessary information to robot to move. And then we display the AI path. Impact and benefits. Digital twins contributes to streamline operations in environments such as warehouse and manufacturing facilities, where automated guide vehicles rely on efficient navigation to minimize bottlenecks and maximize throughput. Various applications beyond robotics, such as drone navigation, autonomous vehicle routing, and also the smart city traffic management, positioning the system as a flexible solution across the automation needs. And finally, we have the environmental sustainability, which is the system optimization for robotics path directly reduce unnecessary movement, thereby lowering energy consumption and contributing to overall eco-friendly practices. For the entrepreneurship opportunities, first one we have a smart warehouse automation solution. Well, this will autonomous the robotic system to the small medium enterprises in logistics and warehousing. We know that this should be a very expensive, and then for SME, we can create a very low and strategic and sustainable and very reliable to the SMEs. Where the product itself is the real-time robot navigation platform for the material handling and load transport using a pathfinding and IoT monitoring. This, the target market is SME that looking to automate their warehouse with affordable, modular, and scalable system. And then for the revenue, we will charge a subscription-based service for the robot management system and the support, and also the hardware leasing. And secondly, we have the opportunity for IoT enabled maintenance monitoring system. The opportunity will commercialize the real-time feedback and alert system using MQTT to support predictive maintenance in the factory. Well, the product is the dashboard, the IoT dashboard that tracks machine or robot health, alert errors, and logs movement in Firebase. And then the target market is for the factory that using legacy equipment looking for affordable upgrades through IoT. The revenue for the model is monthly fee for the dashboard use, plus integration for the chargers. But this is the QR code for the virtual location board, which is I already opened in this. So basically, if you scan the QR code, we direct to this one. Then let's go for the demo. Well, this is the system itself. First, we have the authentication module. So if we have the the wrong email, we directly um, should have error for entering both email and password to log in. And then if we have the register one, we we will register into the Firebase for registration. So if the password is not matched, it will require you to log in and retype the password. And then after we success the verification one, we will we should click the button in the email for register and verify the email. For now, let's go to the login. So if the login successful, will be alert user login successful and waiting for the simulation. Okay, here is the simulation itself. So first one, we have the 3D one. We can move around, we can zoom in and zoom out, we can drag around and zoom in to the robot and to the system itself, the machine, the rack, the material, and so on based on your facilities. And then if we lost where is overall the simulation, we just create the reset view. And then we also provided the 2D architecture for the system to zoom in and zoom out, drag around. If we use it, we just click the reset view. Secondly, we have the locate robot. If we lost count where is the robot is, we just locate the robot, and then the system will show where is the location of the robot. And then also we can turn off and turn on the robots, turn off to see the overall machine architecture, and also turn on to show the machine itself. And third one we have, as you can see, we have the console one, timestamp, all the progress that happening in the system. And also we have the robot speed and also the reset button. And then we also have the show AI path. So for now, we will clicking the button itself. So for now, we as for simulation, I will create two kind of um, bot. So the first one is current robot location, and second one is the other one. So first, if we click the Hulko one, so you see in the system we direct and show a path to the required machine. And also another interesting features, if the robot is at the location itself at the machine that we click, and then the background will turn into green and the other one is will turn into green. So for now, let's redirect the robot. So we will show, and then we can click in real time, and then we can zoom And then we can see the robot movement to the required AI path. And let's see. Yes, so the green one means that location robot is at that location. And then click on the right click the so we can turn off and turn on the AI path, the shortest one, and turn on and turn off again. This is the logout button, and then this is the exit button. So log out, and then we also can exit the simulation.
As a conclusion, we can see that all objective has been achieved. And the conclusion, number one, we success develop digital twin framework for autonomous robot. Second, success create Internet of Things framework for worker or user in this field or industry to call a robot. Third, we success to develop a database and monitor all robot activities. That's all from us. Thank you so much for your time. Assalamualaikum.